All right, guys. So a couple things about matrices. First thing, we've done a lot of this, so hopefully some of this will be reviewed. There are some new things we're going to do, and it's going to build off what we just did with solving, but you're going to need a calculator. All right, so we're going to be doing this Gaussian elimination and all that, but we're going to be able to do most, if not all of it, with a calculator, because your calculator has this great little feature on its matrix section. So anyway, I'm on page whatever, 25, 23, depending on what book I printed for you guys. A couple notes. I'm not giving you a review sheet this time, so if you really want to know what's on your test, do the homework problems. I'm not going to spoon feed it to you. I know some of your heads sharply whipped up and you're like, but I don't do homework unless you collect it, and then I turn it in late for half credit. But some of y'all are smiling because you know that's you. But you're going to need, I mean, you might be fine. You know, a lot of you are rolling the dice, but hopefully you'll do those homework questions. You'll understand what's going to be on that test, and you'll be fine. So what I want to talk about is what Gauss did with matrices. Now, he came up with this Gaussian elimination, but what he did was really useful in the matrix process. Kind of took some of the brain work out of thinking once calculators were developed, because you didn't have to go through this process. Your calculator could crunch it out for you. So there's a couple little things I want to talk about initially. All right, first thing is the fact that we can take something that's like, and I could do this with any size matrix. I could take something like 2x minus 3y plus 5z equals 4, x minus 2y plus z equals 6, 3x plus y minus 2z equals 7. I can take a system, right, and I can write it as in what we call an augmented matrix. Okay, so an augmented matrix, it's really simple. If this has 3 equations, kind of like 3 rows and 4 columns, you're just going to create a 3 by 4 matrix, and you're going to enter all the coefficients. And actually, when you look in the book, a lot of times they'll have this little dotted line to kind of remind you that, oh yeah, those are the coefficients of the variables, and then this is the constant. And you just enter them in, no variables, obviously, because when you go to your calculator, you're just going to be putting the numbers in. And you enter them into an augmented matrix. Okay? Now, we actually learned last year in my class these elementary row operations. That's what Gauss was doing. He was basically, we learned that when we were simplifying determinants or things like that, we could actually add 2 rows or 2 columns together. Can't do columns here, but you can actually add 2 rows together and replace one of the rows with the result. And that should sound like a little bit of what Gauss did. He had that as one of his 3 things you could do. Now, I can't just randomly, I mean, I can randomly walk up and still multiply any row by a number, because this is not a determinant. These stand for equations. So one easy question I might give you on a test is, hey, if this is a system, write the augmented matrix. Another question I might give you is, hey, if this is an augmented matrix, write the system. Now, in that case, if this is all you know, you wouldn't know whether it was X, Y, Z or ABC unless I told you, but you can pick some variables, and then you could actually basically think about this as a system and solve for those variables using whatever method you want. But we have a calculator. And if you go to your calculator, and I'm not going to pull this up because it messes with my, in fact, make sure I got the right speaker on. Yes. Okay, so if you go, I'm not going to pull up the screen like I did a second ago and look at this camera because it switches speakers and I'm all staticky. I think you've experienced that once. But anyway, if you go to your calculator right now, if you don't have one, you ought to get one. There's some you can borrow. If you go to your calculator and turn it on, all right, and when you turn it on, go to the part where you make your calculations. Seriously, go get one if you don't have one. So right here, when you're going to make a calculation like 2 times 3 equals 6. All right, instead, I want you to go to menu. And what do you see down there towards the bottom? Matrices and vectors. And vectors and matrices actually have a lot more to do with each other than you might think. Although we don't get into that in this course, but you might if you were in engineering or something like that, or in advanced math. But we're just going to hit 7. And it says, hey, do you want to create a matrix? Do you want to transpose a matrix? Do you want to find the determinant of? Now, technically, a determinant of a matrix is just a determinant, but you would enter it as a matrix and then take the determinant of it. Right? So if I wanted, remembering that determinants are 3x3s or 2x2s, they're square, not rectangular. But if I ever wanted to find the determinant of something, I would have to like enter the values of it. And before I do that, I could hit det. Hit determinant, and you'll see this pop up, and then you could put a matrix in there, and that's how you would find the determinant. But anyway, that's neither here nor there right this second. You can also, and then you'll see the next couple things, I think, on your calculators, this is an older one, says row echelon form and reduced row echelon form. Okay? Now, if you have the option, reduced row echelon form will get you closer to your answers than row echelon form. But row echelon form, as you will see in a second, means this. Row echelon form will take whatever you have and it will reword. Now, granted, the numbers will change when you do this, but it'll put zeros right here leading each row. So your first row will have basically a bunch of numbers. The second one will have a 0 and a bunch of numbers. The third one will have 2 zeros and a bunch of numbers. But with this exception, row echelon form makes these first 2 numbers 1. Okay? So if you hit something like, if I were to put this in an augmented matrix and do REF, row echelon form of it, now granted, all these other numbers are going to change, right? I mean, lots of stuff's going to be going on here as you do this or whatever. But when these numbers are, when you're finished with these numbers, you're going to have this. Now, at this point, this is why this is helpful. This is now an augmented matrix for what system? Like if you were to go back to the system, it's kind of like the Gauss thing, right? What are you left with here? This stands for the coefficient of x. Sorry, right? Coefficient of x. This is the coefficient of your y. That's the coefficient of your z. I mean, isn't that what I did to go from here to here? Well, if I can get it to this form with row echelon form, I could go back there. I could go no x, 1y, plus 31z. And then this is just what? 1z is 27. So what do I know? I know the z. And if I know the z, what can I do? Plug it back in to find the y. And once I know the y and the z, what can I do? Plug them both back in and find the x. And that would be great. Wouldn't it be awesome if I could type this in, hit REF, the row echelon form, and it magically jumps to this, and I'm ready to go. But there's an even better button. And that's the one below it, which is reduced row echelon form. What reduced row echelon form is not only starts them out with 1s and 0s to the left, but it also puts 0s above and below the 1s, which means that would become a 0. All of these would become 0s like this. And if that happens, what do I essentially know? That 1x is 4, and that 1y is 36, and that 1z is 27. And that's what the reduced row echelon form button does. It basically not just puts 0s there, like we did with Gaussian elimination, but it does even more painful Gaussian elimination to put 0s there. And then it divides by the coefficients to make them 1s and essentially solves your problem for you. Are y'all with me? So this one I just made up, so it probably has pretty ugly answers, and I try to give you nicer, neater answers when you're doing this. But on this test, I really don't need to do that because all you got to do is make sure you type everything in correctly. I do usually give you integral answers, like 2, -7.5, and I do that so if you type it in your calculator and you get crap answers, you're going to go, wait a minute, I probably typed something in wrong. Maybe I hit -2 instead of -3. Because if you're one number off or you forget a sign, more than likely that's going to shift your plane just enough to make it not cross at a pretty number. Are y'all seeing this? So I will rarely ever use row echelon form of some big matrix. I'm probably not going to use that. What I'm going to do is do reduced row echelon form of some matrix. And the reason why is, what's the point of just having ones and making myself back substitute? I've got a calculator, right? Why not just go all the way, get it to something like this, and have my answers just spoon-fed to you? Y'all with me? A little bit? I know I haven't done any of this, but I'm just trying to warm you up. So you're going to be asked again to take a system and write it as an augmented matrix, to take an augmented matrix and write it as a system, whether it's ugly like I had before or really nice like I have now. This would be a really easy system, wouldn't it? Not only is that the system, but it also represents the solutions to that system, if it's in that form. And I'm not going to make you manually go through the pain and suffering of finding zeros there and finding zeros there. Now, if you ever take a coding theory class in engineering or mathematics, then you will probably have to do some of that manually. Well, you did in 1991. With the advancement of calculators, you might not even have to do that now. They might just say it's a waste of time, but probably would have to do it. All right, so back to this sheet. Okay, so looking back at this sheet, number one, it says, write the augmented matrix for the given system. Now, that's a two-variable system, so the augmented matrix would be what size matrix? 2 by 3, and you can see that there. So I'm going to write a matrix right here, right? And when I write the matrix, I'm not going to put the variables in there, right? Just the 2, the -3, and the 12, the 1, and the 16. I usually put a little dotted line to kind of show that it's an augmented matrix that represents a system. And that'd be it. Now, sometimes you see something like this and you go, oh, yeah, that's a 3 by 3. But wait, look at your variables. I've got X's, Y's, and Z's. It's just some are missing, right? So if I want an X, Y, Z augmented matrix, I'm going to have one row for each variable and one row for the constant. So it ends up being a 3 by 4. See, this one has no X's. So 0, 1 Y, 1, -3 Z's, and a 5 constant. This one has 2 X's, no Y, 1 Z, and a -1 constant. And this has 4 X's, -1 Y, no Z's, and a 0 constant. Y'all with me? So that would be the augmented matrix. Now, I haven't done anything with it. But again, at least I know how to do that. I understand what an augmented matrix is. And by the way, for what it's worth, some people, a lot of people, they would call, like I'm going to put it in blue brackets. If I had just this part, just that part, that's called the coefficient matrix. So if I had just that, or maybe just this, I would have what we call right there, the coefficient matrix of this. Are you with me? Okay. So moving on. Now right here, this says use your calculator to write the matrix in reduced row echelon form. So here's what you're going to do. The first thing you want to do is go to your matrix section. And when you see it, go down and hit, mine is 5 for reduced row echelon form. Yours might be a different number depending on what version calculator you have. So I'm going to hit the number 5. And on my paper, I should see RREF. So I should see RREF with parentheses. Okay? Then I go inside the parentheses, which I should be right now, and I'm going to go back to menu, matrix, but this time I'm going to hit 1 for create a matrix. Now, I don't have to do that, but if I do, it's going to say create, and then you're going to have to hit 1 for matrix, and then you're going to have to do the size matrix you want. But let me show you a little shortcut rather than going through all that junk. If you are looking at this right now, right, and you're blinking right there, or your little cursor's right there, go to the left of the book button. If you click the left of the book button, you can see kind of right in the middle, do you see the big 3 by 3 matrix there? You see it? If you click on that, if you don't, please say something now. Don't get behind. If you click on that, it jumps you right to that point where you're like, oh, how many rows or columns do you want? So the other ones actually give you the size that's indicated. Like there are a couple other matrices that look like 2 by 1s or 1 by 2s. They'll give you that size. But the one that's a 3 by 3 lets you create what size you want. Well, what size do I want? So I want 3 rows. So I'm going to leave that as a 3. I'm going to hit tab, and it says columns. I'm going to delete that 3 and put a 4 in, and then hit enter for OK, and it inserts a 3x4. Does everybody see that? Everybody? And now you just fill in the numbers. So fill in the 3, 6, negative 2, 28. Fill in the negative 2, negative 4, 5, negative 37. Fill in the 1, 2, 9, 30, negative 39. Hit enter. And what does it spit out? Let me see. And by the way, tab is the easiest way to move from one thing to another. You just hit tab, it moves. Works a lot better than the whole arrow key. So I've got it all in there. I hit enter, and it spits out this. And I got to be honest with you, this is probably one of the only times when you don't want, like I always have my decimals put on fixed 5. Fixed 5 with a 3x4 fills up your screen. So if you happen to have a 4x5 or a 5x6, which we might have, it won't even show you the whole thing, and you got to scroll over there. So for this and this only, you might want to go to your settings and change this to like 2 decimal places or 3 decimal places. It might fit more in there and let you see more.
How do we go to
Yeah, for your calculator, I think you hit menu, and then at the very bottom of that, you'll see settings. If you have an older one, you got to go up there to the little gear at the top right. Click on that. Go to document settings and change it from fix 5 to like fix 3, maybe. So if I change it to fix 3, what? Why won't it do this? Oh, wait. No, that's still, that's the graphing thing. Do this. Go to, wait a minute. Go to the home page and hit 5. See if that works. No?
It's in the settings wheel for me in the same place.
Yeah, go to when you're in the, when it says settings, just go to.
Oh, no, it works. I just have to re-enter it. Sorry. Yeah, it doesn't adjust what you already did. So just go back up there and grab your reduce your echelon form thing again, bring it down, hit enter, and then you'll see 3 decimals. It'll fit more in there that way. Now, if you get a really big one, like a 6x9, what you'll see is this, guys. Like if this is your screen, you might see this. You might see a matrix, and you might see numbers, and you might see like this ... if the thing gets too big, and that just means you have to scroll to the left. I'll try to get one like that. But again, if I show you this on my screen, then it becomes when I'm talking, and it's really annoying. Sorry. But are y'all with me on this? So because mine spit out this, it spit out 1. Oh, this is a weird one. Check out. Let me talk about this. 1, 2, 0, 6. Why isn't that a 0 right there? But then it spit out 0, 0, 1, negative 5, and then it did this. So what are the rules again? What did I say the rules were for reduced row echelon form? It has to be a 0 above and below each one. That's true. Above and below there are zeros. Above and below, and you have to lead with 1s. But if this ever happens, what did that mean? Remember that from?
It all equals 0.
It means I have infinitely many solutions. It means these 3 planes cross in a what? In a line. And that's where whenever that happens right there, I got to go, well, what do I know? That stands for what? Like 1C or 1Z, depending on what the variables were, which I don't know. But if I said, okay, X, Y, if that's Z, then I know, well, Z is always negative 5. Turns out. But what else do I know? I don't know anything about Y. All I know is that, well, I know a little bit about Y. X plus 2Y equals 6. So what would you do? I can't solve this all in terms of Z because Z is always negative 5. But what can I do? Solve it in terms of X and Y. So if I wanted to, I could take this and say, well, X is 6 minus 2Y. Well, if X is 6 minus 2Y and Z is always negative 5, what do you think Y is? If I'm writing it in terms of Y, Y is Y. So if the question was to write the matrix in reduced or echelon form, I don't have to do any of that. I just circle it and be done. But if the question was to solve by writing the matrix in reduced echelon form first, well, I just solved that system. Okay? Y'all seeing this? And again, that doesn't happen very often. It probably happened because I just wanted to talk about the fact that this doesn't mean you have just, it doesn't mean that you have just ones and zeros here. That's not what reduced or echelon. Reduced or echelon form, each row will lead with a 1, and above and below those ones you have zeros. So look, each row led with a 1 or nothing. This one didn't have anything left, so it led with nothing. So each row led with a 1. This one didn't lead with anything. And above and below were nothing but zeros. That's the definition of reduced or echelon form. And most of the time it does look like a big identity matrix right there. 1, 1, 1 with zeros. Most of the time. But occasionally this stuff pops up.
Would it be possible to get like 0, 0, 0 equals like 5?
Yes. Now, he said, would it be possible in my, and that happened when we were doing Gaussian elimination, right? He said, would it be would it be possible to get on that bottom row this? Like what happens if something like this happens? What does that mean? That 0 equals 5? Well, that doesn't make sense. So this is easy. It's no solution. You don't have to do back substitution or anything on those. That's just where the three planes that were represented by these just happen to never intersect, like the ceiling, the floor, and the wall. They're not going to intersect if they were planes. I mean, technically in real life, they probably would, because there's no way. Like if you ever start remodeling a house, you quickly find that what seems vertical is not vertical. What seems square isn't square. Because who built your house? This might be an insult. Some guy working for $12 an hour, right? I'll get it done. It'll work. Who'll know? I mean, it really does. Like I have a big, it's probably 9 foot, 8 or 9. No, it's not 9. It's probably 7.5 because I remember it fit in my old house. It's a 7.5 foot tall arm wall. And, you know, an arm wall used to be for like clothing. And then people took them in their fancy and turned them into entertainment centers. I was fancy. But that was an entertainment center. For the biggest TV you could buy in like 1997 was a 32-inch tube. It weighed 300 pounds and it had like, I don't know if you remember those. They went back like this far. I mean, you couldn't lift them. I literally, it was 300 pounds. I had to get a friend to come over and help me get it up on them. You had to cut a hole in the back of your arm wall to put it in there. Anyway, why am I talking about arm walls? Oh, yes. So I remember putting it up flush against the wall. And again, in my old house. And it was flush against the wall at the bottom. Well, flush against the baseboard. So a 1/2 inch from the wall. And at the top, 2.5 inches away. Well, my arm wall was plumb. The thing was just, the walls are like this. I mean, everything's off a little bit. In my basement, I was rebuilding out my basement, and I have a 30-foot long wall. And I built this huge entertainment center built into the wall with electrical running through it and everything. I'm actually a bit of a carpenter. Anyway, so it's really cool. The problem was, from the right side to the left side of the room gained 5 inches. Now, you never notice when you're in there. And I think they did it because of water would run out of the house and not pool in the house. So they did it. It's probably an issue of grade, and it's probably something you should do. But when you're trying to build an entertainment center and it goes almost to the ceiling, all of a sudden, and you put the crown mold in, you're like, uh-oh. All of a sudden, it just looks really accentuated because 5 inches isn't much over 30 feet. But when you're putting crown in, then it goes to the ceiling. All of a sudden, you see this weird thing. I had to kind of engineer, and, you know, you can't tell now, but it really took some work to make it where you could tell. Anyway, so whatever. Use variables X, Y, and Z. See, I had to tell you the variable because you wouldn't know. Could be ABC, could be MNP. To write this system back, write the system from the augmented matrix. So what would you say here? And again, this could totally have the dots there if you were looking in your book. So 2x minus y equals 4. You don't need a z there. And then no x, 3y plus z equals -2. And then finally, x minus 3y plus z equals 1. Now, if I was going to solve well, first of all, if I was going to solve, I use my calculator. But if I was going to solve this, I probably would have written these with 0 z's and 0 y's to get them all lined up nicely. But if that's all I have to do, that's fine. What about this? Find the solution to that system. So right here, you can see that this is not quite row echelon form. But what do I have to do to get it in row echelon form? That 2 would have to be a 1, wouldn't it? So I would have to do what here? Yeah, I'd have to divide by 2. And you can kind of see why I didn't make you do that on the last chapter. Because dividing by 2, to me, it makes it a 1, but it also makes that a half and a negative 3 halves. And dividing by 2 there actually is not going to hurt me. It's going to make that a 1 and a negative 2. But you can see I have unnecessary fractions, don't I? So if I was actually putting it in row echelon form, if I had done that of this, it would have led with 1s. I wouldn't have had 0s above and below because that's reduced row echelon form, but it would have led with 1s. But this just said find the solution. So if it just says find the solution, I don't have to do any of that, do I? All I have to do is use what I know about this. And what do I know from that bottom row? That 2z is negative 4, so z is negative 2. And you can jump to there, I don't mind. And then what do you know? 2y plus 1 times z, which is negative 2, is negative 3. So what are you essentially doing here? You're just doing the back substitution process, right? And then once you know both of those, you're plugging those back in. So 1x plus 2 times that y minus that z equals 4. And that gives you a negative 1 and a positive 2 is a positive 1. Subtract, you get x is 3. So the solution would be 3, negative a half, negative 2, which is why I like writing them as coordinates, because that way, whether I used A, B, C, or X, Y, Z, I'd still have the same coordinate because most people do coordinates alphabetically. And I didn't mention anything about coordinates, but your point would look the same either way. Capiche? All right, what about 6? It says find the solution. Now, what do I see here? This is like an X, Y, Z constant, right? So I've got two equations with 3 variables. Kind of sounds like that's sort of the same thing as this, isn't it? So we have a plan for those, don't we? What do we typically do? We say Z is Z and solve. The only reason I didn't do that earlier is because it said Z was always negative 5, so I was stuck with it. Then I went, well, if Z is always negative 5, let me try Y is Y. Make everything in terms of Y. But since Z isn't anything, I'm going to look at this and go, all right, well, this basically means X plus Z is 0. This means Y minus 2Z is 1. So I'm just going to go, all right, let Z is Z, plug the Z in, right? Let Y equals 2Z, plug that in, and look, and then plug them both back in. But look, I didn't even have to plug anything in. I get X is negative Z.
Wait, would it be Y equals 1 plus?
Oh, sorry, yes. Can't forget about that. Yeah, Y equals that plus the 1 that's already there. And then obviously the X is the negative Z. So there will still be times, hopefully, what you learned from the last chapter. And listen, out of this class, there were probably 4 or 5 of you that didn't do well on these. The rest of you in pretty good shape, but there's 4 or 5. So you didn't know it before. You're not going to know it again unless you relearn that. So go back and review what you did on matrices on these that had infinitely many solutions. Make sure you're okay. Don't miss the same thing twice. That makes no sense. All right. And then let's take a look at these. Use Gaussian elimination with augmented matrices to solve. I haven't decided yet whether I'm going to retest you on that again. I may not. But essentially, this is saying do it with matrices. Well, it's the same thing. So I'm going to show you how I would use matrices to do the same thing we did in the last chapter. So recognizing that each spot stands for a different variable. So if I wrote this as an augmented matrix, I would have 1, 1, 1, negative 1, 2, negative 1, negative 3, 12, negative 2, 2, 1, negative 2. So what is my goal when I'm doing this? If I'm doing Gaussian elimination, what's my goal? These 3 spots would need to be 0. So I would have to almost get it to row echelon form. Not reduced row echelon, but almost to row. Although I'm not going to bother making those numbers in the diagonal ones. So what could I do right there to make that first 2 a 0? I could add, this case, I can actually add the second and the third, replace the second with it. And what would that give me right there? I'm going to rewrite it over here. And use as many matrices as you need. So if I add that to that, I get 0. That to that, I get 1. That to that, I get negative 2. That to that, I get 10. And then what else could I do? And by the way, I can't do the same thing again with the same 2 rows and put it there, or I'm going to get an identity. This is all going to cancel. So I can't use row 1 and row 2 to replace this and then do it again to do that, because technically this thing is gone now, isn't it? Technically, I have this. So I can use them again, but look, it's not going to make that a 0. So maybe make the top one, maybe multiply it through by a 2. So I'm going to erase that and multiply this top row by a 2. Now could I add row 1 and row 3 and replace row 3? All right, so I'm taking maybe a little bit more time than I normally would, or a little bit more. But that gives me 0, 4, 3, negative 4. Copy everything else. I hope this feels. And then I'm going to go back and divide by 2. And at this point, I've got 2 of my 3 zeros. What would you do now? Maybe the middle one by a negative 4. That would give me a negative 4, positive 8, negative 40. And if I added those 2, the second and the third together, I'm going to bring it all the way over here to the left. The top row remains unchanged. Add the second to the third, and I get a 0 on the bottom, another 0 on the bottom, an 11, and a negative 44. And I can write the second row down, but I'm going to now go back and divide it by negative 4 to get what I had before, which is a 1, negative 2, 10. Now, is that technically row echelon form? No. What would I have to do to get it in row echelon form? I would have to make that a 1. But that actually works pretty nicely, but it's not a big deal. So I'm not going to ask you to put something in row echelon form. I might ask you to solve, but this is as far as I go. It is way easier to solve for z, plug it in, solve for y, plug them both in, solve for x, than it is to try to find 3 more zeros and to put it all the way in reduced row echelon form, assuming you didn't have a calculator. So I would always stop here and say, well, at this point, 11z is that. So if 11z is negative 44, then z is negative 4. Plug it back in. And what does this second row mean? 1y minus 2 times my new z value is 10. So y ends up being 2. And then if you take both of those and plug them back in, what do you get? 1x plus 1y plus 1 negative 4 equals a negative 1. When you do that, you get an x equal 1. And at that point, you've got your solution.
So it's basically the same thing.
It's the exact same thing, except it's written as a matrix. Now, if on your test, if I did ask you to do this, don't do this. Don't just go. That's not an augmented matrix. Augmented matrices do not have variables in them. Right? I realize you're like, oh, I'm never going to get back to 7 seconds. Well, then don't look at TikTok for 7 seconds. All right? It's not that big of a deal to write an augmented matrix. And in the end of the day, it's a lot easier to work with numbers than letters. All right? It's just that many fewer letters you have to write. But it essentially is the exact same thing I did before. All right. All right, what about this? Use the calculus. I'm going to use the matrix capabilities of your calculator. Now, wait a minute. If I say matrix capabilities, that's a augmented matrix, right? If I said use determinants, that's different. We'll talk about that later. That could be maybe Cramer's rule or something else. But if I say matrices, one of the capabilities of your calculator is reduced row echelon form, right? So why not say, all I would expect to see on your paper is this, RREF, and you could put parentheses if you want, of the matrix 1, 1, 1, and I'm not going to count off if you don't put the dotted lines, but a lot of people do. 2, -1, -1, 2. A lot of books do. So I put the matrix in there, and then all I would expect to see from you is the actual reduced row echelon form, which I would have to do myself. So menu, matrix, 5, book button, 3 by 4, and start entering 1 tab, 1 tab, 1 tab, 3, tab 2, tab -1, tab -1, tab 2, tab 1, tab 1, tab -3, tab 5. And it spits out what? 1, 0, 0. Okay, what happens when you get a decimal? Couldn't you change that to a non-decimal? Don't know how to do that? Okay, go up and grab that. Go up and grab the ugly matrix that has decimals, hit enter. And then I want you to go to menu, number, approximate to fraction, 2. And you'll have a little error that will say approximate to fraction. And when you hit enter then, you see a nice, neat fraction. Did y'all all get that?
Wait, can you repeat?
Yes. Pull up the matrix that had the decimal, and then go menu, number, which on mine it's 2, and then approximate to fraction, which is also 2, and then hit enter. And what you should see is 1, 0, 0, 5/3, 0, 1, 0, 11, 6, 0, 0, 1, -1/2. So what does that mean if it told you to solve? What are your solutions? 5/3, 11, 6, -1/2. All right, guys. I think I did everything except that ugly one. But same thing. Y'all have a good one.